Now that we've practiced computing an instantaneous rate of change, both at a specific point, t equals 1, and for the entire function in general, we can define what we've done. So we define the instantaneous rate of change, which is a mouthful. We don't want to say that too often. We have a much shorter word, derivative, which is what I will normally call it, of a function y equals f of x at a specific point x equals c, such as at x equals 1 or t equals 1 that we did in the first example, is just what we said there. You take the average rate of change between c and c plus h, and you squeeze that h closer and closer and closer to 0, and you see what does this particular number approach. We denote this by the symbol f prime. That's read f prime of c. And now we have to be careful, because in the first week we saw a symbol that was very similar to this, right? We saw an f with a superscript -1. That meant the inverse function. This is something completely different, right? This is the derivative. This tells us the slope of the tangent line to our function at x equals c. So this is how we compute the derivative at a specific number. Now in practice, we often will try to compute it at an unknown place, x or t, just like we did in our first example. And when we do that, we start with a function y equals f of x, and then we end up with a derivative function. Like in our first example, the function was 2t. At any unknown t, we could plug in the t, and it would tell us the slope at that point. So the derivative function is f prime of x. This might not seem too different, but we think about x as being a variable, whereas c over here was a constant. F prime of x is the same thing. The change in y over the change in x, as the change in x gets squeezed closer and closer and closer to 0. So this is our definition of the derivative function, and we're going to be using this function for many weeks to come and enjoying it. So just a brief historical aside here. Newton and Leibniz are the two people who were given credit with developing calculus. They had lots of predecessors that led them along the way, but they were the ones that made the big advance, both around the same time. Newton called his version of this thing a fluxion, and he used the letter O where we use the letter H. Leibniz actually did use the derivative, although he was writing in Latin when he did it. And he had his own notation for this. Neither of them used this prime notation. Leibniz had a very nice notation, which we will use next week. Newton would write a little dot above the y here. So he would write y with a dot above it to indicate the derivative. And you rarely see that nowadays, except once in a while in a physics book. And this f prime notation didn't come about until the French mathematician Lagrange in 1797. And the final thing to say about this is that Newton and Leibniz, today we recognize that they both came up with the idea of calculus independently and around the same time. And they probably both deserve equal credit. At the time, it was a huge controversy. They were fighting back and forth like crazy. Their supporters were going after each other. There were letters exchanged. It was even the royals at the time got involved with this. And it was a really big mess. And it ended up, one consequence of this was actually that although mathematicians could have worked together at the time to come up with some even better math, the British people, the English people, kept separate from the rest of the continent, and really mathematics suffered for some time after that until they sort of reconciled because they were just unwilling to work with each other. I hope we've learned, and we try not to do that sort of thing today. There's a great book called Great Feuds in Mathematics that has a whole chapter about the whole controversy with Newton and Leibniz. If you get your hands on that, I would encourage you to read that if you're interested in the history behind this subject. Now that we've got our definition of the derivative, we're going to practice taking the derivative of several functions in the videos to come.